In this session, we'll take a few problems on arithmetic progression. Here the first one is the sum of all two-digit numbers which when divided by 4 yield 1 as remainder is, these are the options. So it means we want to find the sum of all two-digit numbers which when divided by 4 gives a remainder as 1. Now the two-digit numbers we know that are from 10 to 99. Out of those two-digit numbers we have to select the one which when divided by 4 leaves a remainder 1. So those numbers will be 13, 17, 21 and so on up to 97. Now here this sequence will be an AP, that is arithmetic progression, where the first term A is equal to 13, D is equal to 4, the common difference is 4, and the last term Tn is equal to 97. Now to find the sum, the first step will be to find the total number of terms, that is the value of n. So we can use the formula Tn is equal to A plus n minus 1 into D. Substituting the respective values, Tn is 97 is equal to A is 13 plus n minus 1 into D. D is 4, and solving it we get n is equal to 22. Now we want to find the sum. The summation formula Sn is equal to n by 2 into 2A plus n minus 1 into D. Substituting the respective values, 22 by 2, 2A is 2 into 13, 22 minus 1 into 4, and solving it we get 1210. So therefore the correct answer is 1210, that is option number B. The next one is, if the sum of 3 APs or if the sum of the 3 numbers is in AP is 24, that is the 3 numbers are in AP and their sum is 24 and their product is 440, we want to find the numbers. Now since the 3 numbers are there, so we'll start with the 3 numbers as A minus D, A and A plus D. The sum is 24, so therefore A minus D plus A plus D is equal to 24, D and D cancel, so we get 3A is equal to 24, which means A is equal to 8. Now the product of the numbers is 440, so A minus D into A plus D is equal to 440. Substituting this value of A, 8, so 8 minus D into 8 plus D is 440, and solving it, 8 minus D into 8 plus D is 64 minus D square, A square minus B square form. So bringing this 8 to the right hand side and solving it, we get D square is equal to 9. D square is equal to 9, it means D is equal to plus minus 3. Now when A is equal to 8, A is equal to 8 we got, and D is equal to plus minus 3. When A is equal to 8, D is equal to 3. We get the numbers as 5, 8 and 11. And when it is minus 3, then also we are getting the numbers as 11, 8, 5. So therefore the correct values are 5, 8, 11, that is option B. Now the next is, let sum of n, 2n, 3n terms of AP be S1, S2, S3. That is, we have one AP. If we take the sum of n terms, it is S1, sum of 2n terms is S2, and sum of 3n terms is S3. Now we want to find the value of 3 times of S2 minus S1, whether it's 2S3, S3 or 4S3. So here the answer is S3. Now the sum to n terms is n by 2 into 2A plus n minus 1 into D, so it is S1. Sum to 2n terms, it will be 2n by 2, 2A plus 2n minus 1 into D, and 3n terms, it will be 3n by 2 into 2A plus 3n minus 1 into D. So this is S3. Now we'll start with the expression given. The expression is 3 into S2 minus S1. So substituting the values, we get 3 into S2 minus S1 is equal to 3 into S2. We'll substitute this value minus S1, will substitute this value, and solving it from here, n by 2 and n by 2 we take common. 3 is already there, 3n by 2, and further solving it, we get 3n by 2 into 4a plus 4nd minus 2d minus 2a plus nd minus d, and then again opening the brackets. Finally, we get 3n by 2 into 2a plus 3nd minus d. Now from here we can take d common. It becomes 3n minus 1 into d. Now finally we get an expression 3n by 2 into 2a plus 3n minus 1 into d, which is nothing but S3. So therefore the value of 3 times of S2 minus S1 is equal to S3. Now the next is the sum of first 4 terms of the AP is 56. The sum of last 4 terms of the AP is 112. If the first term is 11, then the number of terms. We want to find the value of n. So here the sum, first let's start with the AP. AP is A plus D, A plus 2D plus so on. Now the sum of the first 4 terms of the AP is 56. So A plus D plus A plus 2D plus A plus 3D is 56. So 4A plus 6D is 56. Further, it is given that the first term A is 11. So 4 into 11 plus 6D is 56, which means D is equal to 2. Now, if Tn is the last term, then the second last will be Tn minus 1, third last will be Tn minus 2, and the next will be Tn minus 3. And the sum of these terms is 112. The Tn is A plus n minus 1d. Tn minus 1 will be A plus n minus 2d, A plus n minus 3, A plus n minus 4, and the total is 112. So 4 is, so 4a, and n minus 1, n minus 2, n minus 3, n minus 4 into this is 112. And then substituting the value of a and d also, the value of d we got 2, and solving all this we get 4n is equal to 44. So therefore n is equal to 11. So the number of terms is equal to 11. Now the next problem is a person buys a scooter for rupees 22,000. He pays rupees 4,000 and agrees to pay the balance in annual installments of rupees 1,000 plus 10% interest on the unpaid amount. Now we want to find the total cost of the scooter. Here the correct answer is B, that is 39,100. Now let's see the procedure. The cost of the scooter is rupees 22,000. He paid down payment of rupees 4,000. So the balance amount that he needs to pay is rupees 18,000. Now he has agreed to pay the balance amount in installments with 10% interest on the remaining amount. So the interest on the first amount will be 18,000 multiplied by 10 over 100 into 1 is 1800. Now therefore the unpaid amount will be 18,000 minus 1,000, which is equal to 17,000, because he has agreed to pay the installments, 18 installments, 1,000 each, so 17,000 is left. Similarly, the interest for the second installment will be 1,700. So we get the installment as 1,800, 1,700, 1,600, and so on. Therefore, the total interest paid will be 1,800 plus 1,700 plus 1,600 plus so on up to 18 times. So here the first term is 1,800, The common difference is 1700 minus 1800, which is minus 100, and the total number of terms is equal to 18. So therefore the total interest will be equal to S, and we'll be using the formula n by 2 into 2a plus n minus 1 into d. So it will be 2 into a is 1800 plus 18 minus 1 n minus 1 into d is the common difference minus 100. Solving all this, we get rupees 17,100. So therefore the cost of the scooter, because the amount that is remaining, the cost of the scooter is 22,000, 4,000 he paid, so 18,000 is the balance amount. He paid 18 installments of 1,000, so 18,000. 4,000 he already paid, so total amount he paid is 22,000. In that, the installments is 17,000, so therefore the total cost of the scooter is 39,100 rupees. Now the next one is, if A1, A2, A3, A4 and so on up to A2N are in AP, then we want to find the value of A1 square minus A2 square plus A3 square minus A4 square plus so on up to A2N minus 1 squared minus A2N squared. A2N is the last term. Now here the correct answer is n over 2n minus 1 into a1 square minus a2n square. Now this is an AP, so therefore the consecutive terms will be having the same difference. So the common difference, a2 minus a1 will be equal to a3 minus a2, will be equal to a2n minus a2n minus 1, it will be equal to d. Now we want to find the value of a1 square minus a2 square plus a3 square minus a4 square. So it will be equal to a1 square minus a2 square and so on. Now this a1 square minus a2 square, we can write it as a1 minus a2 into a1 plus a2. Similarly, a3 square minus a4 square is a3 minus a4 times a3 plus a4. Similarly, the last term, this will be a2n minus 1 minus a2n multiplied by a2n minus 1 plus a2n. Now this a1 minus a2 minus a1 is d, so a1 minus a2 will be minus d. Similarly, this is minus d, so every term will be having minus d. Minus d will take common, so we get a1 plus a2 plus a3 plus a4 plus so on up to a2n. Minus d is out. So now here we can use the summation formula. The total number of the terms is 2n. So 2n by 2 multiplied with a1 plus a2n, because the formula for finding the summation is n by 2 into a plus l. L is the last term. Now we can substitute the value of d. D is equal to a2n minus a1 divided by 2n minus 1. That's the formula for d. And then the remaining thing over here, 2 and 2 cancels, n, and then a1 plus a2n. And further solving it, we get a2n minus a1, and here it is a2n plus a1. So this will be a2n minus a2n whole square minus a1 square, and minus is out, we'll take it inside, so we'll get a1 square minus a2n square, and then the remaining terms n and 2n minus 1. So that will be the correct answer. Now the next problem is, if the roots of the equation x cube minus 12x square plus 39x minus 28 is equal to 0 are in AP, then their common differences plus minus 1, plus minus 2, plus minus 3 or plus minus 4. So here the correct answer is plus minus 3. So the equation given over here is x cube minus 12x square and 39x minus 28 is equal to 0 is a cubic equation. So therefore it will be having 3 roots, and those 3 roots are in AP. So therefore, to start with, we'll start with the 3 roots as a minus d, a and a plus d. Now the summation of the summation of these terms is 3a. D and D will cancel. So, and now we know that whenever we have a cubic expression of the form ax cube plus bx square plus cx plus d is equal to 0, the summation of the roots will be equal to minus b over a. So here minus b over a is minus of minus 12 divided by 1. So therefore 3a is equal to 12 or a is equal to 4. So therefore one of the root is a, because a is one of the root. So one of the root is a. So if one of the root is a, then x minus 4 will be the factor of the given cubic expression. So we can divide this x cube minus 12x square plus 39x minus 28 by x minus 4. So we'll get x square minus 8x plus 7. So therefore x minus 4 into x square minus 8x plus 7 is equal to 0. Factorizing this, x square minus 8x plus 7 is equal to 0. We get x minus 7 and x minus 1. So solving it, we get x is equal to 4, 7, 1. So therefore the roots are 1, 4, 7 or 7, 4, 1. If we take 1, 4, 7, the common difference is 3. That is 4 minus 1, 7 minus 4. And if we take 7, 4, 1, the common difference is 4 minus 7 or 1 minus 4. That is minus 3. So therefore the value of D is plus minus 3. So therefore the common difference is plus minus 3, or the correct answer is C. Now the next problem over here is to find the sum defined by S is equal to summation n is equal to 1 to 10 of 2n plus 1 by 2. It means the general term is 2n plus 1 by 2, and we want to find the sum of all the terms which are obtained by putting n is equal to 1, then n is equal to 2, and n is equal to 3, and so on up to n is equal to 10. So here the options are 110, 15, 120, 125, and so here the correct answer is B, that is 115. Now we want to find the summation of 2n plus 1 by 2. So summation of n is equal to 1 to 10 of 2n plus 1 by 2. We can write it as summation of 2n plus summation of 1 by 2. Now in 2n, 2 is a constant, we can take it out, so it will be equal to 2. Summation n is equal to 1 to 10 of n plus summation n is equal to 1 to 10 of 1 by 2. Now again 1 by 2 is a constant, that also we can take it out, so it will be equal to 2 into summation of n is equal to 1 to 10 plus summation 1 by 2 into summation of n is equal to 1 to 10. Now the first one is the summation of n, and the summation of n, we know that it is n into n plus 1 by 2, and n is 10, so it will be 10 into 10 plus 1 by 2, and this 2 constant will also come in this expression, plus 1 by 2 into summation of summation 1 to 10. It means summation of 1 plus 1 plus 1 plus 1, so on up to 10, so it will be 10, and solving it we get 110, and from here it is 5, so 115, so 115 will be the correct solution. Now the next is, if the sum of n terms of an AP is given by Sn is equal to 3n plus 2n square, then we want to find the common difference of the AP. So here we are getting the common difference is 4. The summation is given as the Sn is equal to 3n plus 2n square. Now if we know the summation till n terms, we can find the nth term. The nth term is equal to Sn minus 1. That is summation till n terms minus summation till n minus 1 term. So Sn is equal to 3n plus 2n square minus Sn minus 1 will be in place of n, will substitute n minus 1 and will solve it. We get 4n plus 1. So therefore the nth term is 4n plus 1. Now the common difference is the difference between two consecutive terms. So if Tn is one term, so its previous term will be Tn minus 1. So therefore the common difference will be equal to Tn minus 1. Tn is 4n plus 1 minus Tn minus 1 will be obtained by substituting n minus 1 in place of n and solving it, we get 4. So therefore the common difference is equal to 4. Now the next one is if A, B, C, D, E, F are in AP, then the value of E minus C. And here the correct answer we are getting is 2 times of D minus C. Now A, B, C, D, E, F are in AP, so therefore the two consecutive terms, any of the two consecutive terms will have a common difference, and that common difference we have denoted here by K. So B minus A will be equal to C minus B, will be equal to D minus C, will be equal to E minus D, will be equal to F minus E is equal to K, where K is a common difference. Now we'll start from this expression, that is D minus C is equal to E minus D. Bringing D on the other side, we get D plus D is 2D is equal to E plus C. So E plus C is equal to 2D. Now this plus C, we can write it as 2C minus C. So we get E minus C plus 2C is equal to 2D. Now we'll bring this 2C to the other side. So E minus C is equal to 2D minus 2C. Because we need the value of E minus C, that's why we have brought it to this expression. E minus C is equal to 2D minus 2C. So E minus C is equal to 2 times of D minus C, taking 2 common. Now here the next is if log 2 and log 2 raised to the power n minus 1 and log 2 raised to the power n plus 3 are in AP, then we want to find the value of n, whether it's equal to 5 by 2 or log 5 base 2, log 5 base 3 or 3 by 2. Now log 2n minus 1, log 2 raised power n plus 3 are in AP. Now whenever three numbers A, B, C are in AP, then 2 times of the middle number, that is 2B, is equal to A plus C. So therefore 2 times of log 2n minus 1 is equal to log 2 plus log 2n plus 3. Now m log n, it means log n raised to the power m. So this becomes log 2 raised power n minus 1 whole raised to the power 2. And this log a plus log b is equal to log ab. So this will be equal to log 2 into 2n plus 3. Now this log and log on both sides will cancel out. So we get 2 raised power n minus 1 whole square is equal to 2 into 2n, 2 raised power n plus 3. Now solving it, we get 2 raised power 2n minus 2 into 2 raised power n plus 1. This is a minus b whole square formula. 2 into 2 raised power n plus 6, and bringing everything on the left hand side, the final equation we get is 2 into 2 raised power 2n minus 4 into 2 raised power n minus 5 is equal to 0. Now we can use the factorization method to factorize it. So we get 2 raised power n minus 5 into 2 raised power n plus 1 is equal to 0. And solving it, we get 2 raised power n is equal to 5, or 2 raised power n is equal to minus 1. Now this 2 raised power n cannot be negative. We cannot have a raised to the power x is equal to a negative value. So therefore 2 raised power n is equal to 5, which means n is equal to log base 2 5. So therefore the correct answer is log base 2 5. Now the next question is based on the arithmetic means. Given that n arithmetic means are inserted between two sets of numbers a to b and 2AB. It means we insert n arithmetic means between A and 2B, and also we insert n arithmetic means between 2A and B, where A and B belonging to the set of real numbers. Now suppose further that mth mean between these two set of APs is same. Now we want to find the value of A is to B. Now the mth mean between the numbers A and 2B, because the two pair of numbers, the one is A 2B, the other is 2A and B. The mth mean are same, so we'll find the mth mean. Mth mean between A and 2B will be equal to A plus m into 2B minus A divided by n plus 1. Similarly, finding the mth mean between 2A and B will be equal to 2A plus m into B minus 2A divided by n plus 1. So therefore these two are equal, and solving it we can bring this A to one side and this is to this side. So finally solving everything, we get A into n minus m plus 1 is equal to Bm. Now we want to find the ratio of A's to B, so we'll bring this B to this side. So A by B is equal to m over n minus m plus 1. Now the next is, if the ratio of the sum of n terms of two APs be 7n plus 1 is to 4n plus 27. Now we want to find the ratio of their 11th terms. So here we are getting the correct answer is 4:3. So if there are two APs and the ratio of their sum to n terms is 7n plus 1 is to 4n plus 27. Now we want to find the ratio of the 11th terms. Now let S and S dash be the sum of n terms of the two APs, and T11 and T11 dash be the respective 11 terms. Now according to the question, the ratio of the sum is 7n plus 1 by 4n plus 27. So therefore S will be n by 2 into 2a plus n minus 1 into d, and similarly S dash will be n by 2 into this. Now n by 2 cancels, a plus n minus 1 divided by 2, we have taken this divided by 2 here, n and n cancel, so 2 and 2 cancel, so a plus n minus 1 2d, and similarly a dash n minus 1 2d dash is equal to this given expression. Now in this expression we'll substitute n is equal to 21. Now why we want to substitute n is equal to 21? Because we want the 11th term, and the 11th term is a plus n minus 1 into d, that is 10 minus 1, so 20. So that's why here we are substituting n is equal to 21, so that we can bring the expression to the form a plus 20d form. So if we substitute n is equal to 21, so solving it we get a plus 10d, and a dash plus 10d dash is equal to 21 substituting over here n and here also, so it is equal to 4 by 3. Now a plus 10d is nothing but it's an 11th term, a dash plus 10d dash is also an 11th term, so therefore the 11th term of the first AP divided by the 11th term of the second AP is equal to 4 by 3, that is the ratio is 4:3. The ratio is 4:3. Now the next one is the sum of n terms of 3 APs whose first term is 1 and the common differences are 1, 2 and 3 are respectively S1, S2, S3. That is, we have 3 APs, the first term is 1 for all, the common differences are 1, 2, 3, and the sums are S1, S2, S3. Now we have to tell which of the relation is true. Now let A1, A2, A3 and D1, D2, D3 be the first term and the common differences of the three APs. The first term, it's already given, it's 1 for all the APs, so A1, A2, A3 is equal to 1. The common difference of the first is 1, second is 2, the third is 3. Now we can use the summation formula to find S1, S2, S3. So S1 is n by 2 into n plus 1. Similarly, S2 is equal to n by 2 into 2n, because the common here difference is 2. And similarly, S3 will be equal to n by 2 into 3n minus 1. Now adding this S1 and S3, we get n by 2 into n plus 1 plus n by 2 into 3n minus 1, and solving it, we get we get over here n by 2 into 4n. Now this 4n we can write it as 2n. So 2 into 2n. So this will be equal to 2. We'll take out 2 into n by 2 into 2n. Now n by 2 into 2n is S2. So therefore it is equal to 2S2. So that's why we got the correct answer over here is 2S3. That is S1 plus S2 is equal to 2S3. Now the next problem is if A, B, C are in AP, then 10 raised to the power AX plus 10, 10 raised to the power BX plus 10 and 10 raised to the power CX plus 10, where X is not equal to 0 are in AP, GP only when X is greater than 0, GP for all X, and GP only when X is less than 0. Now since ABC are in AP, therefore 2B is equal to A plus C. Now multiplying both sides by X, we get 2BX is equal to A plus C into X for all values of X. Now then adding 20 on both sides, if we add 20, so 2BX plus 20 will be equal to A plus CX plus 20. Now this 2BX plus 20 is equal to this, we can write it as AX plus 10 and plus CX plus 10, because 20 we can split as 10 and 10. So therefore 2BX plus 20 is equal to AX plus 10 plus CX plus 10 for all values of X. So it means taking the powers, so 10 raised to the power 2BX plus 20 will be equal to 10 raised to the power AX plus 10 plus CX plus 10. Now this plus, it means the multiplication, so 10 raised power 2 BX plus 10 is equal to 10 raised power AX plus 10 into 10 raised power CX plus 10 for all values of X. Now this 10 raised power 2 BX plus 10, we can write it as 10 BX plus 10 whole square is equal to 10 raised power AX plus 10 and 10 raised power CX plus 10. So now we know that whenever we have B square is equal to A into C, then A, B, C are in GP. So therefore this 10 raised to the power AX plus 10, 10 raised power BX plus 10 and 10 raised power CX plus 10 will be in GP for all values of X except when X is equal to 0. That is, X cannot be equal to 0.